The next structure is the cylinder. Before we begin looking into the formulas relating to cylinder, we need to recap about circles. So what is that we need to look at? We need to look into circumference of the circle and the area of the circle. The circumference of the circle is 2 into pi into r, while the area is pi r square. I would like to analyze this with dimensionally. So here 2 pi is a constant. So this is not to be considered, while r is your variable whose power is 1. So we can see circumference, which is nothing but a length of the perimeter of a circle, right? It's related to length, is it not? Which is one dimensional stuff, and the power is also of one dimension. The power, the highest power, the sum of the powers of the variable is 1. When it comes to area, which is of 2 dimension, we can clearly see pi, which is a constant. We can ignore that. We have the variable part whose power is 2, is it not? So here the power is 2, here the power is 1, and we have this to be of 2 dimension and this to be of 1 dimension. How will this be useful? We'll be understanding it in a bit. So let's move on to look into how a cylinder looks. So this is a right circular cylinder. Okay, so this is not slant, it's up straight, right? You can see this height and the base makes an angle of 90 degree. That's why it's called as a right circular cylinder. So it has a top, it has a bottom, and it has something called as curved surface area. Okay, the sides are of curved surface area. Now, how do you draw this? So in your exam, you can just draw a straight line, something like this, if you guys are not able to, but I would prefer you guys drawing this. And a dotted line indicating the back part. Okay, this is preferable. So you can indicate the radius, you can indicate r unit, you can indicate the height, h unit, and the base radius also will be same. Of course, it can be different, but under cylinder, right circular cylinder, this is only possible. This structure is the only possibility. Okay, so this would be your diagram for your exams. Now, curved surface area version 1. There are 2 versions. So version 1, to explain that, I'll be making use of this circle. Okay, so what is that we are doing? We are going to copy this and paste it. So we're going to do it few times, not going to do it a lot of times, just few times. So you guys can guess how will it look end of it. Right, it's kind of getting obvious now. Right, how does it look? It looks like a cylinder, is it not? Right, it looks like almost a cylinder. So what did we do? We took 2 pi r, so we can talk about the area in this manner. A length 1 into another length 2. So length 1 into length 2 will give us the area. So length 1 was circumference of the circle, which is 1 dimension. Remember, we just saw that. Into length 2 was your height. So what is your formula? 2 pi r h. Is it not? So basically, here we're looking at the circumference of the circle into the height. Okay. So we have the circumference of the circle or the perimeter of the circle into height. This would give you the curved surface area of the cylinder. See, remember, sorry, I did not mention this. We are talking about curved surface area. Okay, we're not talking about, just a second, the entire cylinder. We're just talking about the curved surface area part. The top and the bottom are not spoken of now. We're just talking about the curved surface area part. So we can clearly see that it would be a circumference of a circle, right? One of this being added many times will give you guys your area of the cylinder, curved surface area of the cylinder, to be very specific. Okay, so there is another version of understanding the same, the curved surface area. Again, remember curved surface area. Let me actually just a second, it will take some time, or let me do this. Okay, right, so we can clearly see over here we have a cylinder. If we happen to remove the top and the bottom, so you can clearly see, right, a hollow cylinder. This is your hollow cylinder. So the structure which is making up this hollow cylinder is your curved surface area part. Okay, you got a good view of this. So now let's look into the second way of learning this formula. So we have, see, the same thing but as a paper cutout. Physically I have a cylinder in hand. So first thing is your height. So that is your height of the cylinder. Next is your circumference. Can you see that? That would be not a good circle, but yeah, that would be one of the possible circles. So if this circle is of radius r, what will be the perimeter of the circle? Yes, it would be 2 pi r. So if I open this up, how will it look? What do you think it would be? You can pause and think over. See, it looks like a rectangle, is it not? Okay, so it looks like a rectangle whose base is of length 2 pi r and the height is of h. So rectangle area is what? Rectangle's area is given by length into breadth. So basically the area of this is 2 pi r into h, is it not? Because this is a rectangle. Rectangle is made up of length and breadth. So L into B, here the length happens to be 2 pi r and the breadth happens to be h. And so we have the formula 2 pi r into h. As simple as that. So end of it, we got the same formula. So here too we can see 2 pi r, which is nothing but circumference of the circle, into height will give you the curved surface area of the cylinder. So remember, you need to make use of things which you already know. I'm sure most of you will know circumference of circle and area of the circle. So with that in mind, learn this formula. Okay. Now next is your total surface area. So what is the cylinder made up of? Quite simple. It's made up of a top and a bottom along with the curved surface area. So how does the top look like? Be honest. Whatever you see is what you have. Yes, it's a circle. So since we're talking about area, so basically it is nothing but curved surface area plus top and bottom areas. So curved surface area we just saw, it is nothing but circumference of the circle into height, plus top is the circle. Area of a circle is what? Pi r square. Remember, the radius over here is r, is it not? Here too it's r. So area at the bottom is also, yes, pi r square. So when you solve it a bit further, it is 2 pi r h plus pi r square is 2 pi r square. Again, don't think too much into should I take common and all of that. No, not required. Learn it by part by part. You get questions wherein they talk about you have a box which is placed on the ground, right? It's cemented, and so we are not painting the bottom. We'll be painting the remaining part. How much paint is required? Such questions. How will you answer? Again, I'll repeat the question. You need not So this is not required to be painted. Only the top and the curved surface area has to be painted. How much paint will it require? Can you use this formula? You can, but again, you need to subtract things and all that. That'll be a headache. So understanding that we are just dealing with curved surface area in the top and this other required formula is what you need to think of. This won't be part of the formula in that scenario. So this is how you have to learn. You just need to think, in a way wherein you segregate the diagram and think part by part and then derive the formula for that particular scenario. Okay, so that is your total surface area. Okay, now we'll look into volume. So for volume, I need to have, okay, I am not, yeah, it's here. So we have a circle, right? It's not a cylinder. Have a look at it. It's not a cylinder. I have a circle. Now what will I do? I will copy this and paste it. Oh, just a second. I'm copying this and pasting it. Copy, paste. I'll keep doing this. Copy, paste. So you can, obviously you guys are ready with your answers. How it look like? So how is it looking like? It looks like a, yes, cylinder. Is it not? So let me get back the cylinder. Can you look at it? So it is inside a cylinder. So if I keep doing this, it will be of particular height. So this basically, right, you can see the structure. Obviously it has the inner filling, so I have to consider that as well. So this is nothing but your paper stacked up. So you have a very plain paper. If you stack it up, how does it look? It becomes a cylinder, is it not? So each of this is of, what is the area of each of this? It's nothing but pi r square, because it's nothing but circle, is it not? Area into the third dimension, that is the height, will give you the volume. So volume is nothing but area into the height. So area of what? Area of a circle into the height. So what is the area of a circle? Pi r square into h is your volume of a cylinder. Got it? So you guys generally learn it as pi r square h, but I would advise against learning just like this. You need to remember it this way. Area of the circle into the height will give you the volume of the cylinder. Remembering this way is a lot more helpful than just remembering pi r square h is your volume of a cylinder. That is okay, but again, deriving this way, each of these formulas will help you remember, understand, and apply it in a very particular manner. So it is always useful. Now let me analyze. So remember, I told you we'll analyze what is familiar. So in each of this case, we can see it is related to area of the circle, if not circumference of the circle. So that's how you need to relate them. Once you relate them, then recalling it's not going to be tough. So this was one of the points that I made initially, that we're going to analyze each of this formula in this way. If you're not watching from the first video, please watch it from the first video, because I've told how we're going to study. I've given you different ways of understanding a formula and different aspects of a formula. So if you learn in that manner, sequentially your formulas becomes easier. If you directly jumped over here, this is not the way to study anything. Any of my content has to be learned from first video. I have built the concept on one after another. So sequentially I have built it. So understanding it sequentially is important. If you directly jump in the middle, you feel that I'm going fast. So please don't do that. Okay, now let's look into total surface area, which is of pi r square, 2 pi r h plus 2 pi r square. Right? So this is your total surface area. So here we have 2 pi to be constant, 2 pi to be constant, so we can ignore this. This is r to the power of 1, h to the power of 1, so the power is 2, and this is also of power 2. Should we add them? No. As per exponent formula, only things which are getting multiplied should be, the power should be added. So dimensionally, if you are thinking, there are, even though these are two different variables, we can tell, okay, dimensionally there are 2, the highest power is 2. Since we know that area is of 2 dimension, here we'll get the power to be 2. Okay, again, we are just adding the power, that's all. Don't think too much. Forget about the constants, look only at the variables. Add the power of the variables, whatever the base may be. It's only for dimensional analysis. It's nothing to do with exponents. It's only to understand. So we should add dimensionally. If we need to add something, we should be adding the powers of variables which we are multiplying. So in this case, 1 and 1 will give us 2. It's already 2 over here. So we are looking at 2. The highest, the combined power, and whatever power you want to call it as, it is 2. While the volume, which is given by area of a circle into the third dimension, that is h to the power of 1, the power over here is 3, and this does match with the fact that volumes are 3 dimensional. Can you see this? So this is how you should learn a formula. It will help. Okay. So again, there are different ways that we are looking at. There are different things that we are looking at. So see to that you understand and write everything in a particular manner. Just don't copy the formula. Everything has to be written, whatever we are looking at. Okay, this 1 and 2 and these are dimensional aspect. Okay, so this is what you need to understand. So please pause, write all of it, don't miss anything.